What if I told you there's an invisible barrier, a protective shield stretching from pole to pole? It might sound like science fiction, but it's real, and it's the reason why life as we know it exists on Earth. Today we're going to explore Earth's magnetic field, also known as the geomagnetic field. And when we say it's invisible, we mean it. You can't see it with your eyes, but it's always there, silently protecting us. This colossal force extends thousands of kilometers into space and acts as a gigantic force field, deflecting harmful radiation and charged particles from the sun. But how does it work? Let's start at the heart of the matter, the Earth's core. Imagine a giant ball about the size of Earth's moon made entirely of liquid iron and nickel. That's our planet's outer core. Now picture convection currents, like boiling water, but with molten metal. These currents are set in motion by the heat from Earth's core and the rotation of our planet. Here's where things get really interesting. The Coriolis effect comes into play due to Earth's rotation. It causes a deflection in the movement of these currents, creating a swirling motion in the outer core. Think of it like stirring a pot of water and then suddenly changing the direction. You've probably seen those cool images of magnetic field lines. They're not just for decoration. They represent the path that magnetic field particles take. In Earth's case, these lines start at the magnetic South Pole, travel through space, and wrap around the planet before returning to the magnetic North Pole. It's like a giant, invisible river of magnetic energy flowing from one pole to the other. But it's not a static picture. These lines are in constant motion, shifting and changing due to the churning currents in our planet's core. They twist and turn, some dipping deep into Earth's surface, others extending far out into space. This dynamic interplay between the core and the field is what makes Earth such a unique and habitable planet. The constant motion of the core generates electric currents, which in turn produce the magnetic field. This is known as the geodynamo. It is a beautiful example of how physics and geology come together to create the conditions for life as we know it. But why should you care? Why is understanding this important? As we continue to monitor and explore our world, we're constantly learning more about this invisible shield that protects us. It's not just a scientific curiosity. It's a matter of survival. We're living in an increasingly interconnected world, relying on technology that extends our reach and capabilities. But with great reach comes great risk. The Earth's magnetic field is in constant communication with the sun, and when the sun gets a bit too active, it can send massive bursts of energy our way. These outbursts, known as solar flares and coronal mass ejections, are like massive storms in space. And when they hit our magnetic field, they can cause auroras, sure, but also serious disruptions. Our satellites, power grids, and communication systems can be affected, causing blackouts and system failures. As we continue to push further into the digital age, understanding and protecting ourselves against these threats becomes more crucial than ever. And here's the kicker. We're still in the dark about a lot of it. There's so much we don't know about our magnetic field, its history, its behavior, and what it might tell us about our planet's past. That's why the work of scientists and researchers is so vital. By unraveling the mysteries of our magnetic shield, we're not just satisfying our curiosity, we're safeguarding our future. Every new discovery brings us one step closer to mitigating the risks and harnessing the potential of this incredible natural phenomenon. So keep looking up, because the story of our planet's magnetic field is just beginning. If you like this video, make sure to give it a thumbs up, and don't forget to subscribe for more amazing content. And as always, thanks for watching. We'll see you next time.